afternoon. Good afternoon. Shall I start? Okay, I'll be starting. The next problem in into next problem. Give me a moment. Find the shear force and bending moment diagram for the beam shown in figure. This is the problem statement. 20 kilonewton per meter is the UVL. This is point A, point B, point C, point D, and there is a concentrated load of 30 kilonewton and a moment in the counterclockwise direction 100 kilonewton meter. If this segment, yes, Raghavendra, yes, Raghavendra,
Sir, your voice is very low, sir.
not audible.
No, sir.
Give me a moment. Now is it audible?
No, sir, very low.
Now, now won't it audible?
No, sir.
Hello,
It's too low, sir. It's too low.
hello.
Now how it is?
Aye, sir.
Okay, okay. So what happened is I connected to the mic somehow that is also detecting here. Okay, and each segment it's segment it's 2 meter, 1 meter, and 2 meter. As usual procedure, first right. I find the reaction. Let me copy this suction figure, shear force, and bending moment diagram. Give me a moment. As soon as it give the prompt, you have to find First, the reaction forces, then you have to go ahead. I'll find the reaction forces. I'll call this as I'll call this as RA. Let us take a clockwise movement for confirmation. This unknown moment I have taken clockwise in the clockwise direction. Some student might have doubt. So how can we take only anti-clockwise movement? Let us check this time. Summation of forces in y direction should be equal to 0 for equilibrium, or can I write RA is acting upwards, RA minus 30 minus half into B into H, which is equal to RA is equal to cancels, RA is equal to 50 kilonewton, right? RA is equal to 50 kilonewton. I'll indicate this as 50 kilonewton. 50. Summation of moment of about point A should be equal to 0. That will be equal to MA is acting in the clockwise direction, MA minus this. For bending moment I will take hugging and sighing, this sad and smiley and sad faces, whereas for moment it is positive clockwise and negative anti-clockwise negative. That's the same convention I'll follow. Bending moment, that is hugging and sighing, that we should stick on. Okay, this is MA positive, MA, it is clockwise positive MA. My this is my plus 30 into 2. Okay, this is counterclockwise movement, minus 100 plus, this is concentrated at the point here, entire load of magnitude. I will write half into B into H, half into B into 2, and the distance is, if this is h by 3, h by 3 in the sense 2 by 3, and this entire distance 2 plus 1 plus 2 by 3, that is the moment arm. Okay, can you tell me what is MA plus 60 minus 100 plus 20, 3 3 9 11 by 3. Can you tell me what is the value of MA? How much? How much, Kruti?
Minus 33.3.
Minus 33.334, right? Okay. MA is equal to minus 33.334. It means this negative sign indicates, that my assumed direction of moment is not in the same direction as what we have assumed. It is in the opposite direction. So this MA is not in the clockwise direction. It has to be in the counterclockwise direction. Okay, that you should understand. In the previous class, we have taken MA in the counterclockwise direction. We got positive. But since for confirmation, I took it as clockwise, and we finally will end up with a negative sign. It means to say that MA is in the counterclockwise direction, like this. MA of that magnitude 33.34 kilonewton meter. Next, suction. I'll pass a suction here. X1, X1, X greater than or equal to 0, less than or equal to 2, section AB. If I write the sketch, let me write the forces only. 50 kilonewton acting upwards, 33.334 counterclockwise moment, and a suction X. and the distance, let me call it as x. Okay, from the suction to the left extreme, and I am clubbing all the forces and all the moments from one of the end. That is shear force. That is, and the sum of all the vertical forces from one of the end is shear force. Sum of the all the moments from that particular left hand side end in our context to that suction is our bending moment diagram. Okay. Now if I write shear force, F is equal to summation of vertical forces, which will be equal to this is acting upwards according to our convention. If this is a suction, this is positive. This is the suction. This is negative shear force. Bending moment. This is positive bending moment. Negative bending moment. So I will stick. I will talk about this sagging positive, hogging negative bending moment. Okay, take it to bend it like this, like in the U shape. That is positive. Bend it in the reverse direction. That is negative. Okay, summation of force in the vertical direction is 0. So sorry, summation of force in the vertical direction gives the shear force, that is equal to acting upwards, as in this case is 50 kilonewton is my shear force. Okay, bending moment is equal to summation of moment about xx axis, that is the section xx, 50 into x, 50, this is causing, this is bending the beam like this, bending the beam like this. In the next symmetry, if you assume like this, this is like this is a smiley face, therefore it is positive 50x, and this is counterclockwise movement like this, with from the suction, this is the suction, therefore this is minus 33.34. Moment at x is equal to 0, which is equal to minus 33.334. Moment at x is equal to 2, which is equal to, can you tell me, 100 minus 33.334, can you tell me what is the value?
66.66.
66.66. As soon as you complete that, you should plot the shear force and bending moment diagram. Give me a moment. Okay, I'll you should take the same ABCD. You should not take BC, AB, D, something like that. Then you end up with somewhere we should follow that. However is given the problem, same thing you should follow. B, C, D. If you give A, B, D, you should take A, B, D, or whatever. Then it will be useful for you. At at point at shear force is 50 kilonewton, there is no load, shear force is constant, this is no load, shear force is constant. So when shear force is constant, bending moment is linear, bending moment is linear. Okay, let me draw the shear force first. Shall I continue? Raghavendra, is it audible? Dhruti, Mekhala, Rakesh, Sugun, Abdul Razak, is it audible? Is it audible?
Sir, your
Yes,
voice
sir.
is breaking.
Oh no, it was some instability in the internet. Let me continue. Okay. Now, from A to B, a magnitude of shear force remains the same, 50 kilonewton. Let me draw. There is no load. Shear force is constant, 50 kilonewton from here, 50 kilonewton. Okay. Bending moment at the point at x is equal to 0. At x is equal to 0, it's minus 33.34. At x is equal to 2, 66.66. Minus 33, first let me locate it. 33.334, and then 66 at point at 2 meters, it is 66.664. So shear force is load is 0, shear force is constant, bending moment has to be linear. Bending moment has to, since there is a moment here, there is sudden drop in bending moment like this, and from here it is a linear straight line. It has to be straight line. It has to be straight line from here to here. It is a straight line like this, 66.664. Okay. Next, I will take the section here, x2, x2, segment BC, x greater than or equal to 2, less than or equal to 3. Okay. Let me draw RA 50 kilonewton, 50, moment, how much? Moment is how much? Moment we got 33.334. 33.334. This is point A, point B, 30 kilonewton load, and a moment 100 kilonewton. This is section X. Now you just observe how there will be sudden change in shear force and bending moment. Shear force and bending moment. Since this we are considering this, when you took the section here, this vertical load and moment it didn't come into picture. Where when I took the moment section here, both this point load and the moment will come into picture. You just see how the variation will be. Sudden drop it will be there. Okay. Force is equal to shear force is equal to summation of vertical forces, which is equal to acting force is positive 50 minus 30, which is equal to 20 kilonewton. Okay. Okay. T minus 30, 20 kilonewton. Give me a moment. Okay. 20 kilonewton. Summation of vertical forces 50 minus 30, okay, 20 kilonewton, and then moment summation of moment about xx, which is equal to I'll write it here, uh, 50. This is bending the beam like this, bending the beam about this point like this. It is hogging, which is positive, smiley face. Okay, 50 into x. This moment is in the counterclockwise direction. So write the beam. This is positive, and then this is negative. Moment is acting in the counterclockwise direction, minus 33.34. This is minus 100, minus sorry, this is causing, this is bending the beam, this is bending the beam like this about this point. Okay, this is minus 30 into x minus 2. Okay, tell me the moment at x is equal to 2, which is equal to 100 minus 33.334 minus 100. Okay, minus 0, it will be equal to minus 33.334. Moment at x is equal to 3, which is equal to 150 minus 133.34 minus 30. Can you tell me the value? 150 minus 30 is 120. 120 minus this is minus 13.334. Minus 13.334. Right? Right? Okay. And for this, moment shear force is 20 kilonewton constant. 20 kilonewton shear force. You see, when there is a point load, it suddenly drops to 20 kilonewton. There is a sudden drop or sudden rise when there is a point load. For the shear force, this is 20 kilonewton. Okay, bending moment at x is equal to 2, there's a sudden drop in bending moment minus 33.34, and it will be linear. When the shear force is constant, bending moment is linear minus 33.334 minus 13.334. There will be a drop in bending moment up to this point.